session. Most likely everybody knows me, but not many of you know what I am doing in terms of research. I will explain in not more than 45 minutes probably. My presentations are not very long, usually, but they're very concise. I will give you an update of what is happening in the Internet of Things area. I will give you some hints for the students, how you can test, how you can land your experiments in the area of Open IoT. For researchers or senior researchers, you can see the Open IoT as an opportunity for expand your area of expertise, because it's a green field at the moment. For senior researchers or PIs, it's an opportunity to get new proposals, get it in, and obviously attract investment to Insight. The dynamic is very simple. From the left to right, you will see different presentations, and I will go one by one. You will see the update of Internet of Things on my left. In the center, I will go into application. One example will be the Open IoT project. I will just go into a little bit of details, but not much, because it's related with cloud computing. And in the third one, I will show you the implementations that we have in there in Insight. So some small implementation that is the proof of concept for the Internet of Things. So there is some work done on that area. So the first part of my presentation is research, and then the applied innovation, I call it, and then deployments. Okay. So let's start with the concept of Internet of Things, because everybody is anxious to see what is the Internet of Things happening here. Sorry, that's what started because the remote. I will not use the remote. Okay. So the main concept of Internet of Things is that there are many devices in the market, and all of them are sensors, called sensors. So devices everywhere. So you can see from motor cars in the mountains, even people are wearing devices, or even appliances like Samsung develop all the appliances to put in smart house. But also this kind of enthusiastic devices like Arduino cards or Raspberries, Zigbees that you can even build on. You can go to a toy shop and you can even get a sensor in a toy shop. The idea is to expand this idea and combine it with the evolution of the culture. Nowadays, the society is also changing. Before was afraid of the technology, and now the people is more willing to share information, to share the technology. So this is a cultural change in the Internet of Things. And obviously, these everyday devices are evolving to the virtual world. So you can have applications on the top, like semantic web applications or internet applications, and you combine or you interact with devices. So this interaction bridge a gap or some sort of commonalities that were missing before. And the Internet of Things is targeting precisely those systems that target that one. So in general, there are plenty of sensors in the streets, plenty of sensors developed, and plenty of applications on top of that. So this is what we call interaction between sensors and the Internet. But when we start to create networks, when we start to create links between those sensors, between different technologies, is what we call sensor networks. Sensor networks, we can find typical examples in the fields, like a crow soil, in the cars, which is a typical example and very antique. In the marine applications, you can see sensors. Manufacturing, one of the main areas, one of the main aspects that we can find sensor networks. And obviously this production and logistics. From the time that you send a packet, the sensor networks start to work. There are some RFID sensors and NFC tags that is tracking all the time your product on your packet. And every time you receive in the post offices, they receive the parcel, they scan it, and it's a sensor. So all this kind of a sensor network built. Imagine if you send from Ireland to other part in Australia, so different systems has to be coordinated. So this is what we call a sensor network. However, we need to make these sensor networks intelligent. We need to react, or we need to do it in a more fancy way, to solve more problems that comes with the complexity of those sensor networks. And here is where the Internet of Things come alive. And here is where the Insight activity is taking leadership in this area. So because we have the expertise from the semantic web to attract this information from different sources and combine them and make them more rich, and then create systems that can react to this variation, this richness of data. So when we collect this information from different sensors and different technologies, we can combine we can generate this smartness in the Internet of Things. So this is what it's attractive to the people in the real world when I go and explain the relationship between sensors and semantic web. Obviously, there are many initiatives, there are many definitions of Internet of Things. I will attach to the simplest one. And this is coming from the 1999 in MIT. There is no complications, it's just the interaction between devices and give some smartness on top of that. So whatever is the sensor network is part of the Internet of Things. Okay, there are a lot of literature. You can just go and browse the books, and all of them will coincide in one aspect. It's the interaction between humans and machines. Nowadays, there is no more bridges in between the technology and the humans. I like this graph because Gartner is a very well-known company to do analysis in the market. They take all the emerging technologies and do analysis, and they project how the technology will establish in a few years. So from their curves that they propose, there is a peak of influence, inflated expectations. Usually when you bring with new concept, you say, yeah, this is the best, this is the solution. And it goes with the years to the disillusionment. There is no good goals, there is no challenges to solve. And then the slope come up and then get the plateau of productivity. And here is when the companies take the advantage of that one. Here is the products come up. And if you see the Internet of Things, well, you can see many technologies in this one. This is coming from the April 2013, presently new. Internet of Things is still in the creating expectations, right? So you can see, Martin, then what you're talking about, because in research, we have to go ahead even of the product resolution. But more interesting is, this triangle means more than 10 years will take to the technology to establish or to get into the plateau of productivity. However, in those 3 years, Cisco was saying, yeah, in the real world, we have devices interconnected. For 2010, we will have 1.8 million of devices connected, so more than the population in the world. Billion. More than the population in the world. So we reach all that level of connectivity, but those the services are in place, those the Internet of Things is in place. According to Gartner, in 10 years. According to IBM, on April 2013, they released the first car with the Internet of Things implemented. So who is saying the truth? Who is not working on that? The reality is Internet of Things is here. And we have to take advantage of this one from a research perspective, from an implementation perspective, and from an application perspective. Okay? So this is the first part. I will move into the second part, and you will see some sort of applications. Okay? So in dairy, we have some projects that are working in the area of Internet of Things. Most likely you have seen about Gambas, you have listened about Gambas, or CityPulse, which is one of the new initiatives. Vital, which is another initiative, and OpenIoT. Okay? So these 4 projects are the flagships in the area of Internet of Things. Okay? As you can imagine, in research, there are many initiatives, there are many institutes working in the area in the Internet of Things, but the European Commission established the Internet of Things Research Cluster. The idea of this IERC cluster is to coordinate those activities to avoid overlaps. So they don't found projects that are too similar. So they try to coordinate activities in there. I am the coordinator of the semantic interoperability and service openness in the IERC at the European level. But what we have achieved, or what we have agreed, is that all the projects running at the moment needs to have this impact at the industrial level. So we try to also bring the industrial to the meetings and to the events that we coordinate. So I will describe very briefly every project. I mean, the people listening here, you can go and ask them if you're interested, especially for students that you want to put your experiments in place. Gambas goes into the mobile applications, security and privacy, how the devices can interconnect in a secure way, with a privacy level. CityPulse is more working in the virtual level, doing some reasoning on top. In the previous one, Josie might be the perfect person to describe more in details. In CityPulse, Alessandra can address you to the reasoning part in the virtual applications. In Vital, what we do is when we have different solutions in the virtual world with some sensors attached, so we do on top of that one, we create the management systems that can articulate solutions once that they are implemented. Because the problem is not only create a vertical solution, we have to interact between those verticals. And my favorite example is OpenIoT, because OpenIoT is the niche, or is the starting point of these initiatives. When I start to work as a coordinator in OpenIoT, we saw the potential to expand the idea into a different, to multiple worlds. And then we wrote the proposal in collaboration with the other partners about Vital. So Vital can be the consequence of OpenIoT. And OpenIoT is now in the second year. And Vital just started a few months back. So as you can see the links in between, or the consequences of that. Very briefly, OpenIoT combines technologies like cloud computing, which is my main expertise in Insight. IoT in terms of sensor applications, and obviously the data privacy and security in terms of exchange of information. The idea in OpenIoT is, if you have verticals, let's say you have an industry company working in production of cars or security in the cars, and another company doing the shipping of the materials. So these companies, even if they produce the same item or the same product, they are not compatible at all. They have different reference numbers, different IDs, different systems, and the idea is to put on top OpenIoT, and OpenIoT will enable to share the data that they need to share. It's important because people think, hey, if I am going to the OpenIoT space, I might be sharing my information and it's privacy related. No. You put the data that you want, share with the other technologies, with the other companies, because it's related in favor of your product. Or even better, you just put your data on top, and then another third entity can make a service on top of that. I don't know if you are aware of the Parcel2Go company. So Parcel2Go, what they do is just precisely this example in the logistics. They collect the data from the DHL and all the FedEx, and they offer you even better prices on top because they have deal with the vertical itself. So similar to this one we do with the devices, with the data from the devices. They're coming from the sensors. Obviously, it's more complex because in OpenIoT we have to deal with the data models and information management. In one sentence, because that's the elevator pitch that people ask me every time, what OpenIoT does and what OpenIoT do in terms of services is provide the facilities and the utility management functionalities of the cloud for the sensors, because the cloud plays an important role in here. So we collect the data, we put the access in the cloud, and then we just provide this information. So there are obviously some challenges. There are some applications at the different level. At the real and physical level, we have to deal with the heterogeneity of sensor networks. At the virtualized world, we have to make this self-operability between different verticals. The utility access, we have to provide the tools to end users to create new applications, and I will show you in the next part what kind of applications I'm talking about. And obviously, at the application side, we have to allow applications on the move, that we can migrate from one platform to another platform transparently, with no hesitation. Okay, this is pretty much the design principle for the OpenIoT. It's very typical approach, and you will get more into this one because you know about REST applications, which is the interface for semantic web for the internet, LOD, which is open link data, and that everybody knows in Insight, and obviously the virtual sensor, which might be not the easy to digest concept, but is related with sensors itself. The CoAP is the protocol that we use to translate raw data from the devices into the LOD or into the databases for the OpenIoT. And those databases that rely in REST are not more than triple stores. So then now you can see, okay, so Insight is playing a big role in this one because we are using this type of databases. In the application side, there are some good examples that I will go into details later on, the level of industrial. And so what we have done with this design principle is just expand according to the technology that we have experienced and according with the technology that our partners in OpenIoT has experienced. And as you can see here, OpenIoT relies in the middle of the application and the middlewares. So we have this REST application implemented. SQL is one of the experiments that at the moment we are running to improve the access to the databases. We are enabling streams, linked streams, rather than just data stores triple data stores. We are making more dynamic because in a sensor you can imagine if you want to measure the weather stations, you need to update very often. But how often that has to be to make efficient and don't blow up the channels of the broadband. So this is part of the linked stream analysis that we are running in Insight. And linked data obviously is because there is an open space data set, so we can get that information from there. We use some standards like W3C SSN, which is the ontology for sensor networks. And at the moment, it's getting very well accepted, this approach. We are not coming from the scratch, obviously, because this type of projects are not are mature enough to come up from basis. The basis is coming from the IoT, Internet of Things architecture. They defined a reference model, and then we set it on top of that one, the Internet of Things in Open IoT approach. As I said, there are some standards because we need to come up with and complying with those standards. OGC, the Geospatial Organization, they define the standards for location-based systems. For sensors and sensor app and APIs, we are coming from the W3C community. And obviously for devices and no sensors doesn't even make sense to make specific because there is no specifications. The IEEE is making efforts to define here specifications, but it's still in process. That's why I'm saying the IoT is a green field to everyone, and there are big opportunities for all. This is the big picture of the architecture. You can see here the Open IoT concrete architecture relies on the cloud computing concepts. IoT-A, which is the architecture for management Internet of Things. The requirements from our specific use cases in Open IoT. And obviously there are some background platforms on top. This can give you the big picture of how to design an architecture. So then you might understand how the people start to sell just PowerPoints with diagrams. But as far as you understand this concept, you can translate into components and devices later on, and I will show you how. So this is the IoT-A architecture, just generic concepts: management, security, application, devices, communication channels, IoT services, virtual entities, and business process management. If I overlap the previous architecture with this one, I will come up with something more complex that will start to define the components of my architecture in Open IoT. Quality of service manager, device manager, and all these components are part of the Open IoT architecture implementation. I will go with my software programmers and tell them, I need a module that will do these functionalities. And obviously, we will define the full architecture. At the moment, in the year 2, I'm very glad to say that we have achieved most of the components, except quality of service manager and these two more there. But the objective or the advantage of Open IoT beyond other solutions is that those are standalone components. You can remove them, put it in your application, and they will work. So that's one of the advantages that we are offering. And it comes from the idea of open source project. Because not all the projects are open source. They just develop the solution, they put it in the annals, and they put it into the application. For us, we create a GitHub. So it's open source. You can go download it, test it, and even improve it, and give us feedback, and then start to create more applications on top. I know this is quite in one go, it's difficult to understand, but the message here is Internet of Things is a bunch of technologies that can be enhanced via APIs and via interfaces. It's not something from the other world. So this is a big picture of for a high-level description. All the blocks and diagrams that I showed you before are here, the request definition, the presentation. I will not go in detail to explain what is the process, but the main idea is there are sensors here, there is data coming from here that will be stored in the cloud using the RDF triple stores distributed in the cloud. There will be some schedulers that will listen the requirements from the user. I need to create a service to maybe monitoring the train circulation in Germany. Then this scheduler will go and ask to the database if the information is available. If not, the database will have a service delivery and utility manager that will coordinate the acquisition of those sensor data. Then we'll activate or deactivate the sensor if it's possible, and then get the data and make a presentation of that data. And at the same time, you can imagine, okay, do you have access to the sensors? You can control the sensor? In theory, in the Internet of Things, yes. At the moment in the project, we are still developing the components that will allow us to control the sensors. But we already have the components that allow us to activate the sensor to get the data, to push the data into the cloud. So this is pretty much the big analysis of the architecture. Here are the steps that I just described from 1 to 12. It may be easier to understand that this way. And this is how the functional architecture looks like in functional blocks. Okay, this is coming from 2012. I might need to update it because everything changed with the time. Okay, so the main idea is that the guys in the consortium and people from here in Insight, we have developed some APIs that allow us to show the results of this one. So this one, for instance, is how we can allocate sensors in a map, and we can see how this is the historical records of the sensor, and we can see the performance of the sensor in the time, energy consumption and activation as well. And this is a bigger map with more sensors in the map, and here is the traceability of the records. And this is what is very attractive to the people when we show the Internet of Things, because those sensors are coming from different applications, different domains, even different technology. There is a kind of a configuration and monitoring tool as well. So we can base it on the discovery of sensors around the world or around the application. We can select those sensors and do a monitoring or monitorization of these sensors, but also the activation of those sensors. So you can start to imagine, okay, if I have control of the data coming from specific sensors, I can start to create complex services. Like if the people is going to Derry and it's raining, and I have traffic conditions, I can even estimate what time people will start to work today. So this kind of services on top of that. Okay, so the idea in here is to use the standards. We use the SSN. I will not go in details because obviously most of you will be interested to go and discover the ontologies. But the idea in here is just to relate sensors and sensing. So what sensing is the data and sensor is the device. And then this relationship will be fed by an observation. So this observation is the concept that we are selling in OpenIoT. We can get observations, either from a physical device or from a virtual device. And then we call virtual sensor or physical sensor. And all these relationship and concepts are well specified in the standard from the W3C community that Insight was part, or before Dairy was part of this initiative. Okay, functional blocks is easier to understand many times because this is complex to explain, right? So just imagine that all these components are implemented. We need to create the ontology and use the ontology to specify the OpenIoT data coming up. The advantage or the difference between SSN and OpenIoT data models is that we use clouds. Okay, we have to we design and we define it, the concept from the cloud and put it into the OpenIoT. So now we have this interaction between domains as well. Okay, so I will just go. Who is using SSN? A part of the project that we are coordinating, or the project that I push to coordinate and use that technologies is OpenIoT, Spitfire, some other projects like IoT-A, Sensor Grid, CSSR in UK, and all these companies are using officially the SSN in all their implementations. Okay. If you want to know more about OpenIoT, obviously the website and the publications are in the portal, and I will not go more in details about that one because the idea is just to give you the taste of how the Internet of Things and how the application side is happening in Europe. Okay, the last part, which is the IoT deployment and implementation examples, I will just show you some scenarios that we have in the OpenIoT. Eric, can you just go to the next one? There are three main scenarios: manufacturing, smart cities, and agri-food and Phenonet. So as you can imagine, it's industry, smart industries, and smart cities. These are the keywords. Everywhere you go and talk about IoT, Internet of Things, you will listen, oh, smart cities scenarios, yeah, that's the keyword, the buzzword. I will show you how manufacturing we have developed our solution for manufacturing, and you will see how easy it is to create services on top of that. Next one, please. This is the real application. This is how it works in Athens. There's a Sensap is one small company, an SME, that produce packages for medicines or packaging for any product. This is particularly for medicines. They have to identify between colors because they have different color code. They have to count this is the color identification sensor. They have to count the number of reps in the production line for the machines, to monitor the machines. And they have to count the packages that comes, the boxes, the carton boxes that pass in the production line. And they also has to tag the put an identification. So these are real sensors, and they can obviously have raw data from them. The idea to use OpenIoT is to make it more efficient, because if they do this manually or based on the performance of the machines, they most of the time has overplus or overproduction, or maybe sometimes shortage in the materials. So we help them to solve this problem, and the solution was to create dynamic services that can be applied to different demands. So you can imagine that producing a small package for a medicine is not the same problem that is not the same effort that it requires to produce maybe a big parcel box. So every time they have to change the production, they adapt to the production line, they have to change the sensors. They have to even plan a new layout in the production line. With this approach, using OpenIoT, they don't need to change anything, because the sensors are in place, and sometimes the sensors are remotely. They don't have the sensors in the plant. They just go to the warehouse and check which sensor is activated, and then they just bring the sensor in here. The idea in here, and I will show you in this screen. It's a realistic video. Sorry. For some reason, I just close it. Second. Okay, it's here. So this is the production line in Athens, in the company called Sensap. This is how they traditionally do the identification of the products. They have this type of tablets. This is the previous model. This is the current model using OpenIoT. I will more advanced come up, and the sensors are coming from the pictures that I showed you before. Obviously, the requirements are identified. I will just jump into the sensor. Here's the counting. Here's the color code in the identification, and obviously here the quantity production line. Yeah, here is how they count the pieces. And the idea in here is just to produce the online services. See, here is a tablet. They put it in a tablet because they found it more fancy to carry on for supervisors and bring the tablets. But there is also a fixed station. Here is a fixed station where the people just use it in the production line. Here is how you create a service. You can create a matrix of different sensors, bunch of virtual sensors, bring it in here. Or you can define the number of sensors, the matrix, 2 by 2 or 3 by 6, whatever sensors you want to get from the production line. And here in the example is the color identification, and also the performance of the production line, and also the performance of the counting devices. Yeah, you can customize them. You define the type of sensor, which is already in the database, and also you define the type of lecture that you want to perform, and all this customization that you can do to sensors. Okay. Once that you create the sensor on the fly, you just carry on into the path, and then at the end you will have a bunch of sensors that you want to monitor in. And this case is a monitoring performance, monitoring of production line, and monitoring of the warehouse production. So different areas, different applications bring it into the same platform. So here are the monitors of them. And then once that you create it on the fly, you just run it, and it should work like this. Okay, you create it, you put it, and in the background obviously is working, and you will see this performance on the back. This is the interface with the real sensors. GSN is one of the platforms that we use to interact with the real sensors, and we get the data from there. This is how semantically the sensors are described. GSN can annotate the sensors, and we can even go and see. This is more for developers, but in general, or the concept is based on the fly, you can define new services. And then you can even locate the sensors in the map to see. This application is quite fancy because the owner of the company is always traveling, and he wants to see what sensors are working and what sensors are not working. Because he's an SME and he doesn't have too much people to hire. So he just make a call and say, okay, I need that technician to replace that sensor because it's not working, or to check what's happening with that sensor. Because he has 2 or 3 companies like that. Okay, so coming back to the application, maybe the next slide. Okay, so this is the screenshots that I took from the video. Next one. The other scenario is smart cities. Smart cities is one of the applications, more extended applications. I mean, good in time. Next one, please. And here, you can see here is the realization of smart monitoring, crowd sensing monitoring. I don't know if all of you were here last year, actually no, 2 years ago, when we produced the Volvo Ocean Race app. The idea in the Volvo Ocean Race app was to have in the mobile phone the variation, the mobility of the people in the event. So we have visitors around 2,000 people, and the idea is to see how the mass of the crowds moves between the places in the city. And without any privacy issues, because we just said that we will just take the GPS coordinates, we will not personalize the coordinates. And the idea is to see that variation on here. So this is how we can see the triple store coming from the different interfaces in that application in Volvo Ocean Race. And this, we run an experiment. Before putting it into the app, in USM Group, we run an experiment, and we collect data from, open data from Dublin, from 3 main cities in Ireland. And you see here are 3 months, most likely, from 3 days, sorry, from the December 28th, 2012, from the 28th of July until the 30th of July. So we collect this data in Dublin. Also, we collected in Cork, and we collected in Galway. And coincidentally, there are the 3 bigger cities in Ireland, and if we overlap, we can see that in some cities the activity is reduced compared with other cities. And that's because obviously there are more, the conclusions of this one was because in Galway there are more events, more festivals. So people keep more active during the day. Even in the timeline is more extended. In Cork and Dublin, is the activity relies more into the lunch times, because the activity reduced in lunchtime because people used to have to go for having lunch in the Stephen's Green, and all together go to that place. So all these statistics are not easy to digest if you don't have these graphs. And also what we are trying to do, what we will do for the next year in OpenIoT is to do a little bit of reasoning, to precisely to come up with some sort of conclusions like that. Okay. So it's very, I'm very enthusiastic with this project because it's an open source and everybody will be accessible, will be able to contribute on that. So this is an example how we can create clusters in the Volvo Ocean Race, how we create clusters to see the grouping of people. It's not easy to see in a small map. There are 50 people in one point, so we need to create clusters and make this one. Do use some algorithms like this one. Obviously, in these particular scenarios, this is just more like generic. There are some challenges that we need to achieve. Sensor networks, we need to satisfy sensor networks. We need to provide the tools to get the information from the sensors. We need to provide the middleware to enable that data and put it into the top. And in terms of open source, it has to be physically or at least distributed in an easy way that can be standalone installed. And in cloud computing, we need to create this model of services as a platform as a service. So you have to install, and you have also to provide the interfaces to billing, accountability, performance, and all that's included in the OpenIoT. And obviously, the development of these applications requires information exchange, interoperability of the information. And in terms of management, we have to visualize these sensors. We have to perform activities on those sensors, and we have to activate or deactivate those sensors. And here is where the next part and the last one is coming into place. So as I said, we have these 3 main areas, just as summarized. And one of the problems that haven't been achieved, And here is the more challenging part in Open IoT: information interoperability, open services, heterogeneous systems, and future internet networks and cloud. So as I said, pretty much the project is going in a good direction and achieving all of them. Okay, so there are some technologies in the background working on that. There are some obviously publications. We have to achieve this objective. Some more publications that are accessible. And the idea is to show you in this last part, next one, is how we can articulate in theory, in insight, because it sounds like it's a good project, it's a good collaboration project, but what we are doing in the project itself, what insight is, what is the role of insight in this Internet of Things adventure. So we are supporting the Superstream Collider idea. In here, what we do is just collide data sets, stream data sets, mashups, and obviously we offer that all the data sets are in the cloud, either for storage but mainly for processing. So we can run parallel processing or multiple queries at the same time, supporting via Superstream Collider. So this is one of the tools that we are promoting. We are putting efforts in this one. And obviously, there are some functionalities like query builder, data source transformation, mashup engine, mashup visual editor that our students or the team in USM is building up. And obviously, there are some services on top that we don't go in this domain, but at least we provide the interfaces or the APIs to demonstrate that it's accessible, it's possible. Okay. Here's how we do the mashup discovery, or we just collide different sources and put it through the Superstream Collider, and we just get an answer via simple queries, via Sparkle. Okay. This is a big picture of how you can combine data sources with applications via Superstream Collider, following this process: acquisition, transformation, representation, queries, processing, and visualization. This is the simple service life cycle of the data that we promote in Insight, or at least in the USM group with sensor data. Okay, so the idea in here is you can see the transformation between real sensor data, streaming data, and the virtual data. So this is how the meta models can be mapped between different domains, and everybody knows about how to do this one somehow in Insight. Okay. Last but not least, how we can create a query. For those experts in Sparkle, this is not very functional, but for people that is not expert in Sparkle, you don't need to learn the language. You just carry on functionalities from the left, carry on to the right. What you have to do is just follow a logic that is defined in the tool, and you create your own query. This is how to create a code, a query with a specific code. And then once that you create the query, you just next one. You just visualize. You just visualize the query. Oh, maybe it's missing. Here must be the editor of the queries, okay? But it's missing. Okay, this is how you do it graphically. Instead of doing programming line, you just concatenate or link different streams, traffic sensor, RDF, SQLs, and you just visualize the results of the query. Here's the query, and here's the result. So basically, using this graph concatenation. Okay. This is another visualization. You want to use widgets from Google. You just can visualize the performance of the sensors. Okay. Another visualization of weather stations, triplets. Another visualization of LSM discovery, how you can discover sensors. And this is how you can combine. This is the algorithm that I defined to make the concatenation in Superstream Collider. So it's not very complex, but it's efficient at the moment. So we will see if I need to modify it. Next one. There is an editor area, as I explained. As easy as you just carry on from one side to another side. You don't need to learn much about the tool, just carry on. Next one. And next one. For instance, this is an example of how to trigger information from Twitter. Just create, we create a sensor, virtual sensor that connects with Twitter, and we just look for the beer festival keyword, and we just bring all the content from the streams. So keep in mind that this is a stream. It's not a data sensor. It's a stream actively being modified. Okay, next one. I'm nearly at the end. Next one, probably. I need to jump this one. Okay, This is the service life cycle representation of the data. As I said, we have to bring the data from physical devices, transform it into a data that is annotated, and then do some adaptation between different applications, interoperability mainly. And then on the top, we need to activate applications and services. And the missing part, or the ongoing part, research part, is how to do this reverse process. From the top of the application, then go into the transformation, get the data according to the sensor, and then go to the sensor and control the sensor, which is the most challenging part. For that one, we have Samuel Michalek here present, and he's working in this using co-op protocols. Next one. This is the architecture for that particular implementation in co-op. The idea is having the protocol. If we know the result of the application and we know the source of the data, we just use reverse engineering to go into the sensor, because we can assume what type of sensor is it. So we have the L4DS sensor. We can define the sensor in here, and we transform from this description into the Sparkle or objects using HTTP protocol. Next one. Here is an example. I might go just fast. And what we have done, Samuel have done, is he interconnect sensor devices, the sensor in here, light sensor, with a lamp, traditional example of activating the activated lamps. This is not science behind, but the semantic come up in terms of activation and deactivation when we use the tool to visualize and to activate and deactivate. And we use Minecraft. Yeah. To visualize and deactivate this one. You can see here the light is off, and semantically describe it in Minecraft. You can see the light is off, and then when you activated the light, or when the sensor is it's triggered when the sensor triggers the lamp, then in Minecraft you can see this one, and you can control the light via Minecraft with some functionalities in here to activate and deactivate using co-op in the background. And obviously everything is described via triplets. Okay, so next one. This is the graphical representation of the architecture. So how we can have sensors and actuators, and you need to go up to the clients and following the service life cycle of the data that I described it. Next one. And this is how the application looks like in a more described. So Minecraft is in the background. Okay. Next one. As you can see, just to conclude, Open IoT is a bunch of opportunities. There are many areas, from IT networks to security, transportation, industrial applications, healthcare, consumer home, energy. Open IoT is just a small bunch of this one in here. So you can imagine how many other opportunities you will have for your experiments, for new opportunities, for new budget support, for new research projects. So, next one. The message here is whatever is your data set, or whatever is your experiment that you're running, can be part of a sensor. So you can enable your data to be part of a sensor, and then that information can be used for triggering different applications. I have more examples about other technologies that we have in USM, but as I said, I don't want to use more than 45 minutes. But the RFID and NFCs, next one, was used here maybe 2 years ago or 3 years ago. You might remember this application. You have your RFID tags, and just when you get proxy to the antenna or to the reader, you are identified. Next one. You are identified by the system, and then your FOV profile is created, and then in the display your profile is shown in the format of business card. So what it really means is every person come to the display can be identified, and the added value or the services on top of that application is that all the people that are in the room and has been identified and somehow has a link with you, because maybe he's working in the same project, maybe he's working in the same topics of research, or for some reason there are links, can be shown in the background. Okay, if you approach, okay, I am the only one working in cloud computing. No, there are more people working in cloud computing. Maybe I can even browse them. And then in that time, that demonstration It was just the kinetic movements, and then you just browse the business cards from one side to another side. So you see, and the deployment of the technology was the minimum, just RFID cards and one reader, and the rest was just sniff the information from the sensors that we have available. Next one. And well, this one is the map in the office, how it was deployed. Next one. The world version race already explained. Maybe just bypass quickly. Next one. So here is some screens. LSM, next one. LSM is how to visualize the sensors around the world. Next one. Next one. Sorry, next one, just because of time. Okay, here you can have the map and you can have the sensors around the map. Those are sensors that are activated. If you go online, LSM, it's not here, lsmdairy.ie, then you can see this platform working. You just click or make a zoom in the area that you want to see, and you will see the sensors popping up. You just click on the sensor and you will get the data from the sensor. It's open data, you just get the data. Next one. This is an example, for instance, in London, you click on the traffic cam and you just get the triple data or the raw data. If you click in the raw data, you will get the data like this one. If you go into the triple, you can get the triples, subject, object, predicate, but also you can get the real image of the sensor. So it's very simple. Next one. Another example how you can get the triples. This is for flights, and this is for rail, for train stations. This is the ball washing race, how you can see the data. Okay, next one. I think I'm at the end. This is how you can manage this is probably the next steps, because obviously the project will not finish and we will put everything in the trash bin. So we will continue doing analytics on top. We will still have some plans for doing reasoning and analytics. And the idea is to enable those services that has been created already on top and make more interaction between them. Pretty much what Vital will do, but at the service level. Vital will do it at the sensor level or the application level, but we will do it at the service level, probably the next proposal that we will submit it in the next call. Okay, the other example of next steps is the applications of healthcare applications. The idea in here is to have, in this scenario is cardiovascular monitoring. You will have access to the databases on the world that you have about the electrocardiograms, and then you can analyze your results with those applications. And then the differences or the tendencies, you can see a tendency, and if it's a bad tendency, you can even suggest go to the doctor because maybe you can be propense to have a heart attack. But if you see a variation that is not expected, then it's having a problem at the moment. So you might even detect or predict something. And obviously everything is based on cloud infrastructures, and the diagnosis is part of the reasoning part that we are working in the group. Okay? If you see something interesting that you want to work as a student or as a researcher, just contact us. And this is pretty much my presentation. Thank you.